You probably check the weather every single day, right? It tells you whether you need a heavy coat or if it's a shorts kind of day. But have you ever stopped to think about what those numbers, Fahrenheit, Celsius, Kelvin, really truly mean? I mean, where did they even come from? Well, today we're going to dive into the pretty amazing story of how we figured out how to measure hot and cold.
Okay, so let me ask you something right off the bat. 20 degrees. Is that hot or is that cold? Well, if you're in the US, you're probably thinking about a light jacket. But if you live almost anywhere else on Earth, that's a beautiful, pleasant t-shirt kind of day. And if you're a scientist, well, you're getting dangerously close to the coldest temperature possible. The answer, as you can see, completely depends on the scale you're using.
And that's really the heart of the matter. For most of human history, the best we could do was just vague words. It's hot. It's cold. It's kind of lukewarm. There was absolutely no universal, reliable way to put a number on it. But that all started to change back in the 18th century, thanks to one really clever guy. Our first stop on this journey is with the man whose name is still on thermostats all across the United States, Daniel Gabriel Fahrenheit. And you gotta understand, he wasn't just slapping numbers on a stick. He was trying to create a standard, something that anyone, anywhere could reproduce.
So, in 1724, Fahrenheit had two huge breakthroughs. First, he perfected the mercury thermometer, which was a huge deal, making it way more accurate and reliable. But the real game changer was giving it a standardized scale. For the very first time, two different thermometers could finally agree on what the temperature actually was. So, how in the world did he pick these numbers? I know, they seem totally random, but for him, it was all about what he could do in his lab. 0 degrees was the absolute coldest temperature he could reliably make, over and over again, using a mix of ice, water, and salt. 32 was the freezing point of just plain water, and he set 96 as his best guess for the human body's temperature. It was all about consistency.
Now, the scale did get a little tune-up later on. It was adjusted just enough so that the boiling point of water landed on a nice, round 212 degrees. And this little tweak is actually why we now say a healthy body temperature is closer to 98.6, not the 96 that Fahrenheit originally used.
So, look, Fahrenheit's system totally worked. It was reliable, it was standardized, it was a massive leap forward. But you gotta admit, the numbers 32, 212, they aren't exactly clean or intuitive, are they? This kind of left the door wide open for someone to come up with a system built less for a specific lab and more for the clean logic of science. And that brings us to our next big innovator, a Swedish astronomer named Anders Celsius, who had a much simpler, way more elegant idea. Celsius looked at the problem and basically thought, come on, why not build a scale around the two most important states of water that we all know? He imagined this really neat 100-step ladder, which is what centigrade means, running from freezing to boiling. It was a brilliant idea for scientists everywhere, except he set it up in a very, very weird way. And here is the twist that just blows my mind. Celsius originally set the boiling point of water to 0 and the freezing point to 100. Yeah, you heard that right. His scale was completely upside down compared to what we use today. Colder days meant bigger numbers. So why on earth would he do that? It seems completely bonkers, right? Well, the reason was actually super practical. Living in Sweden, he got really tired of having to write down negative numbers all winter long. By setting the freezing point at 100, pretty much every temperature he ever had to record would be a nice, simple positive number. Okay, so as you can probably guess, this whole upside-down thing, it didn't last very long. Not long after Celsius passed away, a few other scientists like Jean-Pierre Christine and Carl Linnaeus basically said, yeah, let's flip this thing. So they inverted it to the standard we all know now, 0 for freezing, 100 for boiling. And then much later, in 1948, the scale was officially renamed Celsius in his honor. So we have Fahrenheit, we have Celsius, but even with these two, there was still a huge, fundamental question just hanging in the air. How cold can things possibly get? I mean, is there a bottom? The search for that ultimate limit is what brings us to our final scale. So in the 19th century, scientists had a huge breakthrough. They realized that heat isn't some weird substance, it's just energy. Specifically, it's the motion of tiny atoms and molecules. The faster they jiggle around, the hotter something is. So if you think about it, there must be a point where all of that motion just stops.
That theoretical floor, where it's impossible to get any colder, is called absolute zero.
And a physicist named William Thomson, who you probably know better as Lord Kelvin, did the math. He figured out that this point of perfect, absolute stillness, the coldest temperature possible anywhere in the universe, happens at precisely -273.15 degrees Celsius.
And so, Kelvin created a brand new scale, one designed purely for science. It starts at the true bottom, at 0K, which is absolute zero. No more negative numbers. And here's the brilliant part. He made each step, each Kelvin, exactly the same size as 1 degree Celsius. This makes the math for scientific calculations an absolute dream.
All right, so now we have our three main players, Fahrenheit, Celsius, and Kelvin. They're all talking about the same thing, how hot or cold it is, but they're speaking different languages. So the next logical question is, how do we translate between them?
Well, if you want to speak all three of these temperature languages, it all comes down, not surprisingly, to a little bit of math. Each scale is connected to the others through a set formula, which lets us convert any temperature from one system to any other.
And you can see right away how beautiful and simple that Celsius to Kelvin relationship is. Because their steps are the same size, you just add or subtract 273.15. Easy. Converting to or from Fahrenheit? Well, that one's a bit more of a beast. Because it has a different 0 point and a different step size, you've got to use that kind of clumsy 9/5 ratio.
So after this whole journey, from Fahrenheit's quirky but reliable lab points, to Celsius's logical scale based on water, all the way to Kelvin's absolute scientific standard, it kind of makes you wonder, doesn't it? We have this universal language for temperature in science, so why do a few countries still hold on to Fahrenheit? Is it just old habits and tradition, or is there maybe something more to it? That's definitely something to think about the next time you check the weather.